So by the time food gets to the duodenum, that soupy mixture called chyme, okay, it's been mixed in with gastric juices. It's got a very, very low pH, which means it's super acidic. If that soupy mixture was to go through the small intestine like that, it would probably eat a hole through the intestine very quickly. Okay, so your body does a couple things to the chyme when it gets into the duodenum. The duodenum is the third and final site of chemical digestion. The first one being the mouth with the amylase. The second one being the stomach with the pepsin for the amino acids and the protein. And hydrochloric acid for the finishing of carbs and the beginning of fats. Now the duodenum does two things. Number one, it raises the pH of the chyme, or that is the location where the pH of the chyme is raised. And that's done by what organ? The pancreas, okay? Now, the pancreas has a duct that dumps into the duodenum. And what is it that it's going to be dumping in to raise the pH from 2 to about 7? Sodium bicarbonate, okay, NaCO3, also known as baking soda, just saying, okay. When you take things like Tums, if you've got heartburn, Tums is actually calcium carbonate, and it's the carbonate here that is basic, okay. The carbonate is what's important, and that's what's going to raise the pH, okay. So the sodium bicarbonate brings it from a pH of 2 to about 7.2. So it rises considerably. That's a really, really good thing. Okay? So, but that doesn't really have any digestive properties to it. That is not a part of chemical digestion. What ends up happening to finish the digestion of fats? What gets secreted into the duodenum? Bile from two places. It'll come from the gallbladder, okay? And number two, it can also come from the liver. So the bile helps finish, so bile, okay, finishes fat digestion. So that means proteins and fats are finished in the actual duodenum. Carbs are finished in the stomach, whereas proteins and fats are started in the stomach. And that is chemical digestion. So this is just an idea of the comparison between the small intestine and the large intestine. Both of these intestines are the site of absorption. Okay, they absorb all of those 6 nutrients that we have. Carbohydrates, proteins or amino acids, fatty acids, vitamins, minerals, and water. Okay, those are the 6. And somewhere within these 2 organs, they go from being inside the chyme to being into the bloodstream. And once they're in the bloodstream, technically, they can go anywhere in the body, to any of the cells that need them. Okay? So the vast majority, the vast majority of the nutrients get absorbed first in the small intestine. And the small intestine does that by making, okay, these little projections inside of it, where these projections increase the surface area that is exposed to the actual chyme. Because if we take, okay, if we were to take this inner kind of lining and start it right here, and we were to stretch it out, it would be this long, the length of the screen, let's say. But if we look back to our other page and we're only going to take, you know, the inside of this without any undulations, well then that only makes it about this long. So which of these linings are longer? The one with the villi is longer. So villi, and all along these little projections, we have little blood vessels, okay? We've got a network of blood vessels that line this, and they go up, okay, in here. And basically, these villi are only a couple cells thick. They're so tiny and thin. And so as the chyme passes through them, they absorb, okay, it goes from the actual bloodstream. So we get our different molecules go from being into the chyme, and they make their way into the bloodstream. And they do this through two forms of transport. Active transport and passive transport, right? The vast majority of, now what gets absorbed here, we've got carbs, we've got proteins, so amino acids. Our fatty acids are absorbed here, and our vitamins. Okay? The vast majority of these get absorbed through active transport, which means it costs energy. Okay? Once the chyme, that soupy mixture, gets to the end of the small intestine, the vast majority, pretty much all of the carbs, amino acids, fats, and vitamins have been taken out. Okay, some vitamins are small enough that they will get absorbed later on in the large intestine, but for the most, all vitamins in the small intestine. Okay? Now, if we look at this guy, so if I'm to take one villi here, okay, so if I'm to circle this guy right here, and let's make this guy a little bit bigger here. Okay, so we've got the actual basis. There's a villi, okay? I've got a blood vessel that is pretty much coming very, very close to the surface of the villi. And what's really, really cool here is that on top of this, to even make it that much more surface area, I've got even these small little projections on the top of this guy. Okay, and these are called, what are those guys called? Oops. Oh well. My microvilli seem to have disappeared. But anyway, the microvilli just increase the surface area that much more. Okay, and so what happens here is these actual, if I'm going to make this nice and thick, what ends up happening here, all right, so if I want to actually draw out the microvilli here, and I will, let's go here. So if I've got my little microvilli that are built into my villi, they are very, very close to my actual blood vessel on the inside of the actual, okay, and this is a huge magnification, obviously, but the blood vessel itself is very, very close to the ends of the villi and the microvilli. So what happens when we have this substance in here full of our nutrients, okay, our nutrients will actually go from an area on the outside or inside the actual, interior of the small intestine. They'll cross this barrier and they'll go into the bloodstream. Okay? Now, fast forward this to the large intestine, and what are the last two actual minerals left? Water and minerals. Water and minerals are the last two nutrients left. Okay, so if I've got a cross section, all right, let's actually just draw a section of, because let's say the large, and it's not as nice and neat as that. So there's my large intestine. Again, I'm going to have blood vessels that are lining this, okay? And it's not as neat as this. But what ends up happening here is inside the feces, you will have lots and lots of minerals left over. They have not been absorbed yet. And if there's a high concentration of minerals inside the digestive system, but not in the blood, where are the minerals going to want to go? Into the blood. They're going to want to cross this barrier and dump into the blood. And when we have something that goes from an area of high concentration to low concentration, it does not cost us energy. This is a passive form of transport called what? Now, the interesting thing with this is that once the minerals go flying over, well, then they become highly, highly concentrated, and this causes a lot of the water that is left in the feces to want to follow, because there's now more water in the feces than there is in the blood passing by. So what ends up happening here is the water is going to go from an area of high concentration in the feces to an area of low concentration in the blood. Now, when water behaves like diffusion, we call it osmosis. And that is the movement of water from an area of high concentration, where there's lots, to an area of low concentration. So that by the time that feces gets to the end of the line here, the vast majority of the water the body needed has been taken out. It's more solid than it was. Put it this way, if you were to get rid of what was right here, that would be diarrhea. And if you're getting rid of what's right here, that is more solid poop. Okay?